Hello everyone. In today's class, let us study about non-exact differential equation. In the previous classes, we have studied about exact differential equation, the meaning of exact differential equation and all. Suppose the given equation is not exact differential equation, then we can multiply that equation by terms called as integrating factor. By that factor, the equation will be exact. So in this class, we study about that the equations that can be made exact by multiplying certain factors called integrating factors. Suppose let us consider one differential equation mx dx, or directly m dx into n dy equal to 0. The basic format, which is not an exact function. That means this equation cannot be expressed in the form of derivative of some other function u. If we multiply the whole equation called some other function mu to this equation will become exact. Now the challenge is, what is the value of this mu? And we will study some 5 methods to find this mu. This mu is called as integrating factor. Okay, for example, if you have one in a differential equation y dx plus dy equal to 0, clearly you can see this is not an exact differential equation, because this equation cannot be put in the form derivative of some other function u, where u is a function of x and y. But you can see here, if you multiply this equation by e raised to x, then this will be e raised to x into y dx plus e raised to x into dy equal to 0. Applying the necessary and sufficient condition to this, which is dou m by dou y should be equal to dou n by dou x, then only we call this equation as exact, right? So let us check this condition for the given equation. Here the value of m is e raised to x into y. Value of n is e raised to x. So dou m by dou y, differentiating m with respect to y, this will be derivative of m with respect to y implies e raised to x is constant. Derivative of y with respect to y is 1. E raised to x will come. Dou n by dou x. So again, derivative of e raised to x is e raised to x itself. Now you can see this, dou m by dou y is equal to dou n by dou x, which is equal to e raised to x. This implies the equation which we have multiplied e raised to x to this equation become exact. So in this case, e raised to x, what we have multiplied to this, is the integrating factor. Am I clear? Okay. So now we have 5 rules. Let us see one by one. Rules for finding integrating factors. Let us take m dx plus n dy equal to 0 be a non-exact differential equation. If m dx plus n dy equal to 0 be a homogeneous equation in x and y with same degree, then 1 divided by mx plus ny is the integrating factor. Here this mx plus ny, that means the term in the denominator should not be equal to 0. Second rule is, if this m dx plus n dy equal to 0, this is for homogeneous, right? This m dx plus n dy equal to 0 is of the form y into some function of x comma y dx plus x into some function of x comma y dy equal to 0. If this equation can be put in the form this, then 1 divided by mx minus ny is the integrating factor. Here you note that the term in the denominator, which is mx minus ny, should not be equal to 0. These are the two rules. The third one is, suppose dou m by dou y minus dou n by dou x divided by n is a function of x only. Function of x means that is in the form f of x, right? Then e raised to integration of f of x dx is the integrating factor. If this term is the function of x only, then e raised to f of integration of f of x dx is the integrating factor. We have the proof for this, which is very important from the point of examination also. Let us take m dx plus n dy equal to 0 be a non-exact differential equation. Let us consider mu be the integrating factor. Okay. Then if you multiply this to this, we get the exact differential equation, right? So we'll multiply together. Mu into m dx plus mu into n dy equal to mu into 0 is 0, which is exact. So now it will become the term m. It will become the term n after multiplying mu, right? So applying the condition, we have dou m by dou y and dou n by dou x should be equal to 0 if this equation is exact. Here dou m by dou y, in the place of m we have mu into m, and dou n by dou x, the value of n is mu into n for this equation. I am taking for this. Now we get mu into dou m by dou y plus m into dou mu by dou y. Mu into m is there. With respect to y, we need to differentiate. Will be equal to dou mu by dou x into n plus mu into dou n by dou x. Here I am differentiating term by term, applying the product rule. If you take mu outside, then we get dou m by dou y and dou n by dou x. But if you take this term to this, it will become negative, equal to n into dou mu by dou x minus m into dou mu by dou y. Again, if dou m by dou y minus dou n by dou x divided by n is a function of x only, we are applying the condition, then it is a function of x only, then dou mu by dou y will be equal to, function with respect to y will be equal to 0, because which is a function of x only. Now substituting this value, we get mu into dou m by dou y minus dou n by dou x equal to n into dou mu by dou x, because dou mu by dou y term will be 0. This implies dou m by dou y minus dou n by dou x equal to 1 by mu times n into dou mu by dou x. Here we know that, again I am rearranging dou m by dou y minus dou n by dou y x divided by n equal to 1 by mu into dou mu by dou x. Just rearranging, but this is the function of x equal to 1 by mu into dou mu by dou x. Therefore, f of x, here dou x is there, these are all the function of x only, then we cannot take this as partial derivative. This will become complete derivative because this is a function of x only. Only one independent variable is there. So we cannot take a d instead of dou. So f of x into dx equal to 1 by mu into d mu. Am I correct? Therefore, now this is the variables are separated. Now we can use separable variable form to find the solution for this. So integration of f of x dx equal to log mu. Am I correct? I am neglecting the integrating factor. Therefore, mu equal to e raised to integration of f of x dx. Mu means integrating factor, which will be equal to e raised to integration of f of x dx. Am I clear? Okay. The next rule is this. That was the proof, and the next rule is if m dx plus n dy equal to 0 is again non-exact differential equation. Then if dou n by dou x minus dou m by dou y divided by m is the function of y only, then e raised to integration of f of y dy is the integrating factor. This the proof will be same as in the previous case. You can do that. Okay. And the fifth one is, if the given differential equation is of the form x raised to a into y raised to b into my dx plus nx dy plus x raised to c into y raised to d ly dx plus kx dy equal to 0, then x raised to r into y raised to s is taken as the integrating factor, which is the next rule. Here r and s, where r and s can be found by multiplying the integrating factor x raised to r into y raised to s to the equation and satisfying the exactness condition. Exactness condition. Like this, we find the integrating factor. By all the 5 cases, we get the non-exact differential equation as exact differential equation. Okay, let us solve problems based on this 5 types, very important types, 5 types in the next class. Am I clear? Okay. If you are having doubts, you can text me.